So, as I said, Capgemini is a consultancy. So we've got a number of different clients that we've worked with in the serverless space. I'm going to talk to you today about one particular client, a utilities company, because I think it gives us a good idea about kind of the breadth of serverless, how we implemented it, and how we actually faced challenges and accelerated their business delivery, which is kind of the key for them. So what was the ask? The ask was by this utility company was to have a brand relaunch. They had a hard date that they said, right, we want to relaunch our brand with a new website, which turned actually to be two different websites because it was two sub-brands. And within that as well, they wanted to create a new pricing mechanism. So showing the customers through a journey how they could price their gas and electric for 1, 3, 5 years, and then allowing them to sign up to that service. So taking payment details and direct debit mandates so they could actually do that. And the final one is putting the service live and actually keeping it supported and running, which is quite a big one as well. So there were a number of challenges before we even walked through the door that we knew about. The first one was that there was already a third party who tried to implement the solution for the websites. This was written in serverless framework, so we were picking up and working with that, but more on that later. The second one was the AWS environment that we were working with was managed in-house by the utilities company, which might not sound like a big challenge, but when you've got to work with them to get to access and permissions and all these other things, it becomes quite quickly that it is that. And the biggest one is a 2-month go-live date. So from the moment we walked through the door to this delivery, it had to be done in 2 months. So no small ask. All of this would lead into the successful go-live criteria. But also as well, we have to think about the stakeholders. And keeping stakeholders happy is also a success criteria. So it's not just the people that engaged us, which was the marketing team, but it's the other stakeholders as well. So people like the architecture team, does it fit in with their holistic architecture and their enterprise architecture? The security team, how do you work with them to help them understand that serverless is just as secure or even more secure than their existing on-prem solution? So we took a view that we would work with all these stakeholders in 3 different areas, which is cost, speed, and quality. And what I'm going to talk through now is these 3 key areas, how we modified the existing solution to what we worked with, and then some of the key lessons learned around each of these areas. So the first one was costs. So license costs are very big on the current on-prem solution. So things like Windows licenses, Oracle licenses. So we wanted to turn that on its head and say, well, actually, if you move to a serverless model, you can strip all that away. So you can actually pay for just pure compute. The second one is always on. So you've got these big boxes that you're always paying for. They're constantly working, and you've got big production loads that are scaled for peak, but you're paying for cost. You're paying for capacity you're not always using. And the same with the dev test environments. Some of them are going to be built to scale, and it's not very cost effective. So again, we suggested that you move to the serverless pay-per-use model. So actually, as we've seen in previous talks today, you can actually link value to a click. So you can say, my user is going on this journey, and I am paying for that as a result, but you're also getting value back. And the last one is high support costs. So what's one of the biggest costs is actually the 5 people that are sitting there supporting these boxes, supporting these services. So if you can cut that team down and actually have it as managed services, then you're going to be in a much better place. So what cost savings did we have? So we predicted that we would be able to deliver 50% cost savings from the current model. We actually achieved 75%, which is quite a big one. So what lessons did we learn along the way? 96% of the costs, and this is taken from live run costs, were from 4 services. And these services were actually more traditional infrastructure services, things like NAT gateways and databases. The certificates manager in AWS was rather expensive as well, considering we were only holding 2 certificates. And the actual serverless costs, so things like your Lambdas, your S3s, your API gateways, was only 1% of our overall cost. Speed. So the next one is talking about speed, and this was one of the key pieces that we needed to work with the marketing team. So we had 2 monthly release cycles on the existing on-prem solution, and we've already said it was 2 months till go-live date. So obviously these two weren't going to mesh. We wanted to move to an on-demand release. So as soon as something was ready, it was tested, it would be shipped to production. So how do we manage that? We did it by breaking down this single big release. So this big code base that was previously done, it was all set there, and we took it and re-architected it. So we said we want to break everything down to its components. We want to have it all stored and be able to deploy at a very, very granular level. So per Lambda, per bucket, all these sorts of things you would deploy as individuals, so it wouldn't knock on and have that effect. And the challenge with having single big releases is the downtime window. So when you were deploying to the full service, you'd have downtime of your website, which obviously isn't good for customer interaction. So we switched that up by having blue-green deploys and just DNS switching on the front end to cut that out completely. So we see on this slide that we've talked about having 4 releases a day with 0 downtime. Now this is slightly out of date because last night we did 8 deploys in a day. So slightly out of date there, but I thought I'd highlight that. So what were some of the unexpected elements that we saw when we were talking about speed? So RDS was one of the big ones, so the managed database from AWS. We were using for our price book, which is the pricing strategy within the RDS database, a snapshotting. So the idea is that we would create the price book in a lower environment and then promote it up through the environments with our Terraform script. Now the challenge with this is, if you use snapshotting, then it tears down your database and rebuilds it from scratch, which isn't ideal. So that was taking 45 minutes. So obviously that was putting a blocker on our pipeline. For production, it wasn't too painful because we'd have the blue-green deploys, but for our test environments, it really slowed us down there. The second one is CloudFront. So if you wanted to put any changes on your CloudFront distribution, such as things like origin for an S3 bucket, or some of your header lambdas, which we use for security on the front end, then it would take 30 minutes to propagate through, which isn't always an issue because you're not taking any downtime, but if you've got new features, then it takes a while for the users to be able to see that. And the rollback methodology as well. So we've talked about the split methodology we had with the serverless framework that was handed over to us, and the fact that we built out the quote and join pieces within Terraform, but they work in different ways in the way that they roll back. So serverless framework will roll your state back to the last known good configuration, whereas Terraform will roll forwards and leave your state half finished until you fix it. So that's something to figure out as well when you're talking about speed. So quality. Quality is an overall encompassing piece. There's quite a lot in here as well. So you're not just talking about application security, you're talking about other things as well, such as non-functional requirements and performance of the application as well. But we're going to focus on security, as that was one of the stakeholders. So we had boxes that weren't consistent between environments. So you'd have development on one version, you'd have test and prod on completely different versions, different patches being applied to different environments, and even sometimes different operating systems. So you couldn't tell what was the application challenge and what was actually a configuration challenge. So you're probably all sick of hearing this already, but config as code was our solution to this. I think we've heard that a number of times today. So everything was shipped all the way through. So our dev environment was exactly the same as all of our other testing environments and our production environments, which wasn't too popular with some of the developers who are used to getting access directly to the database to debug, but we've solved that problem, so if you're interested in that, come talk to us as well. The on-premise solution as well was using a single firewall gate. So the idea is that you push all of your traffic through one point of entry, so you can see what's coming in, what's going out, and you can log all that traffic. Now that doesn't work so well in a serverless framework. When you're using things like a CDN on the front, it's very difficult to actually pass all that traffic through. And it's not actually particularly secure either, because you've got multiple firewalls sitting throughout your systems with security groups. So that was one thing we wanted to change, was actually splitting that out. and monitoring as well. So the current solution only had infrastructure monitoring. So what was going on those boxes and what was the uptime of the site. So we changed that as well, and we optimized that to say, well, not only do we care what's happening within the infrastructure, but we care what's happening within the application. So very granular level logging for the application and journey management throughout that as well. So our objective was set to be as secure as the existing solution. So this is something that the security group worked with us on to say, if you can pass this as external penetration tests and be as secure as our existing solution, we will accept that. We actually got a better security rating, which was a big boon for us. So what were some of the unexpected items we saw? So when working in AWS, the ACLs have a hard 40 rule limit. Not a big deal if you've got, you know your IPs that you're working with. So you say you've got a private subnet and you've got one or two connecting services to that. What becomes more challenging is when you start to connect to external services, such as SES or Oracle, for instance, and they cycle their IPs, or they have a port range. So you quite quickly hit that limit. The second one was buckets by default. They actually communicate in clear text, or you can communicate them in clear text. So you have to apply a policy to that bucket to get it to do HTTPS by default. Edge Lambdas. We've covered this point at the moment already, as you can actually, on your CloudFront distribution, inject headers into and from your Lambdas for your front end. So actually introduce more security elements, things like stop clickjacking and no sniff through injection of headers. And if you want to work with TSL 1.2 as well, or one of the other versions, it doesn't come as standard for the API gateway, so you need to put another CloudFront instance in front of that to filter that traffic through for that security. So what were some of the things that we learned from a technical improvement? We talked about the RDS snapshots, which took 45 minutes. Obviously, this wasn't an acceptable thing we wanted to deal with, so we wrote some new Lambdas to actually do SQL injection directly into the database to achieve that. Now, to take it to that next step, we actually want to refactor that whole way that we're doing the database. So moving that data to an S3 bucket to get rid of that, not only the cost challenge that we saw before, but the speed challenge as well in that. The serverless website we touched on briefly as well, so the serverless framework that we were using, and the fact that we put in Terraform as well, so we had two technologies working side by side. Now, we've kind of cobbled these together with some scripts so they actually do work together, but eventually we'd like to split all of our Terraform, convert that all into, all of our serverless into Terraform. Slow Lambdas. So when you put a Lambda inside a VPC, it has a startup time. So it's a cold Lambda, and you have a startup time. Usually when it's outside of a VPC, you don't really notice this impact. But when it's actually inside a VPC, you notice it quite a lot. So it can take up to 10 seconds to bring up within a VPC, which when you've got a front end and a user waiting for a reaction to happen, you can't afford 10 seconds on the front end. So we pre-warn those Lambdas. So we keep them alive with a CloudWatch ping, just to keep them there so that you could have that interaction. And what we'd like to do is split that out even further to say, what do we actually got in terms of Lambdas that need to be within VPCs or outside VPCs, and really optimize how that works. API gateways. So when you get an API gateway, you get a spurious cause issue. Every time you ping that gateway and you've got a bucket, you actually have to code in to that. There's the cause, so the region, cross-regional. You have to code that into the code itself. So we added that in. But also as well, most logs that come back from the API gateway will tell you you've got a cause issue. So you actually have to send proper logs back to tell you what the real issue is. So what do we learn in terms of the business lessons? We've walked through the technical ones, and now we move on to the business lessons. Alignment. Alignment is a huge piece. When we went in and started our journey with our client, we knew who the stakeholders were, but we possibly didn't align as well as we could have. So we went into a security meeting. We talked about the single firewall before, and the security team were insistent on all the traffic needs to be going through this one single firewall. We didn't want that to work in the serverless world because it would obviously throttle and bottleneck all of the traffic going through there. So this took a week out of our project for us to walk through with them, for them to be comfortable that we could actually do this in a manner that was not only as secure, but more secure. So if we'd have brought them on the journey earlier, it means we would have avoided that week gap, and a week in a 2-month project is a huge thing. Architecture as well. So we talked a bit about the differences between a serverless architecture and an on-prem architecture. And we really need to think about how you convert one to the other. So it's not a simple lift and shift from on-prem into the cloud, into serverless. You need to think about how you're going to break down your application and how you're going to manage all of that within the framework. And the big takeaway from this is that it was a success. I think it was a big piece and a big win for us to be able to deliver this in such short time frames. The application was stable, and all the stakeholders are happy. So again, if you've got any questions or thoughts on this, please do come and talk to us. And that's it from me. Thank you very much.